Welcome to a second lesson in statistics and hypothesis testing for independence and homogeneity. In the previous video, we talked about the goodness of fit test, and we were looking at the chi-squared distribution. We will be using the chi-squared distribution again for contingency tables. And in this particular lesson, we will focus on the hypothesis test of independence, and here where the row and column variables are independent or dependent. So what is a contingency table? A contingency table, or a two-way frequency table, is a table in which frequencies correspond to two variables. One of the variables is used to categorize rows, and a second variable is used to categorize columns. Contingency tables have at least two rows and at least two columns. Again, there are basic requirements to use a contingency table and to run the chi-squared test for independence. For one of them, the sample data are randomly selected. The sample data are represented in frequency counts in a two-way table. And for every cell in the contingency table, the expected frequency, E, is at least 5. Now again, there's no requirement that every observed frequency must be at least 5, but the calculation of the expected frequency should be at least 5. And again, there's no requirement that the population must have a normal distribution or any other specific distribution. So you do not need to test for normality when doing this. Okay, so let's talk about what independence means. The test of independence tests the null hypothesis that in a contingency table, the row and column variables are independent. And this procedure cannot be used to establish a direct cause and effect link between the variables in question. The dependence means there is only a relationship between the two variables. Then what it does is if, for example, we do have a statistically significant result, that tells us that we need to dig deeper to see what's actually happening. Perhaps there is a relationship between that can be explained by logic. Again, a relationship doesn't necessarily mean that one causes the other. So let's take a look. Here's an example that we will be using soon. We will be actually looking at two examples in this video. One of them is to test if a nurse is a serial killer, and the other one we're going to be looking at is some data from the Titanic disaster in 1912. So when we're testing for independence, the contingency tables will see that if the row and column variables are independent of each other. The null hypothesis is that the row and column variables are independent. There is no relationship between what's happening with the row variables and the column variables. They have no association. The alternate hypothesis is that the row and column variables are dependent and there is some relationship that exists. We will be using notation if you're wondering how these are calculated. We will not spend time calculating it by hand, but I will show you how you can calculate any of these by hand if you'd like. So notation, we will use O to represent the observed frequency in a cell for a contingency table. We will use E to represent the expected frequency in a cell, again found by assuming that the row and column variables are independent. Lowercase r represents the number of rows in the contingency table. We don't count labels when we do that. We're just counting the number of actual rows of data. And similarly, small letter c will represent the number of columns in a contingency table, and again, we're not including labels. The test statistic is calculated the same way that you saw the chi-squared distribution when we did the goodness of fit test. So chi-squared is equal to the sum of all the observed minus expected, that value squared, all divided by the expected frequency. To find the expected frequency, what we do is we take the row total, which can be determined in the contingency table, times the column total, and once you have that product, you divide it by the grand total of all to find the expected value for any cell. And I will describe that once we get to that particular part of the lesson, like how you would actually do it if need to be done. To find critical values, we again you could use a table or we could use Minitab Express. In this lesson, we will be using Minitab Express, but any software program should be able to generate a chi-squared distribution plot and also help you determine what the critical value is that separates the region of rejection from the region of retention. Okay, the tests of independence are always going to be right-tailed. And then again, when we look at the degrees of freedom, this is a little bit different. What you do is you take the number of rows minus 1, and you take the number of columns minus 1. You multiply those two together, and that gives you the degree of freedom for that particular analysis. Again, remember those individual components of a hypothesis test. You'd identify the null and alternative hypothesis from a given claim, expressed both in symbolic form. You'd also be determining what your claim and counterclaim are as well. Identify your critical values. You calculate the value of the test statistic, identify the p-value, and then you state the conclusion regarding the null hypothesis and in the context of the problem. And again, a couple of things. In the particular case of independence, if there's two possibilities. Either we reject the null hypothesis and conclude that there is sufficient evidence to warrant rejection of the claim, or we fail to reject the null hypothesis and conclude there's not sufficient evidence to warrant the rejection of the claim. Now, rejecting the null hypothesis means that there's some relationship between the row and column variables. They are dependent. If you fail to reject the null hypothesis, this would imply that the row and column variables are independent, meaning that they have nothing to do with each other. So let's start. Is the nurse a serial killer? And this can be looked up in any, if you ever look it up, you can find that Kristen Gilbert's biography. It's in Wikipedia. Again, the source where it was inspired was from the Troll Elementary Statistics book. So this is how it goes. 3 alert nurses at the Veterans Fair Medical Center in Northampton, Massachusetts, noticed an unusually high number of deaths at times when another nurse, Kristen Gilbert, was working. Those same nurses noticed missing supplies of the drug epinephrine, which is a synthetic adrenaline that stimulates the heart. They reported their concerns and an investigation followed. Kristen Gilbert was arrested and charged with 4 counts of murder and 2 counts of attempted murder. When seeking a grand jury indictment, prosecutors provided a key piece of evidence consisting of the table below. So here you see shifts with a death, shifts without a death, when Gilbert was working and when Gilbert was not working. Viewed another way, if we put it on a bar graph, the numbers in the two-way table might be better understood with a graph such as the bar graph below, which shows the death rates when Gilbert was working and when she was not working. The bar graph seems to show that the patient death rate was much higher when Gilbert was working, this is right over here, versus when she was not. So we need to determine whether these results are statistically significant. Again, is it just due to chance, or is there something else going on where we need to dig deeper? So that's what we're going to take a look at. So we are going to run a test of independence. We'll use a significance level of 0.01 to conduct a series analysis of data, and we're going to test a claim that deaths on shifts are independent of whether Kristen Gilbert was working. So we'll do that. After running the analysis, what does the result suggest about the charge that Gilbert killed patients? So we're going to present all the components of a formal hypothesis test. So we're going to take a look at a couple things. So let's first of all look at the data. One of the things we're going to do is determine what the critical values that we're going to be doing, also based on the distribution. And so over here, what it is, I've already entered the data into Minitab using the labels and pretty much recreating that two-way table that you saw in the PowerPoint. Okay, so the first thing we want to do is determine what the distribution is. It's going to be chi-squared. Now, when we look at this two-way table, which is over here, what we noticed is that, let's go back a step here. In the two-way table, it has 2 rows and 2 columns. So to find out the degrees of freedom, what we would do is take, okay, row minus 1 would be 1, and column minus 1 would also be 1. And then the calculated degrees of freedom, df, it would be the 1 from the r minus 1 and 1 from the c minus 1. So that's 1 times 1, which is 1. The degrees of freedom for this particular question will be 1. Okay, so let's now go and, using that knowledge, we're going to look up the probability. We're going to go to the distribution plot. We're going to display the probability. We want to switch over to a chi-square distribution. It's going to ask the degrees of freedom, which is 1. And we're going to be doing this for significance of 0.01. This is going to produce a chi-squared distribution graph. Let's take a look. So over here, when we look at this, it tells us that our critical value is going to be 6.63490. So we're going to use that as our critical value that determines the region of rejection. And right here under the area under the curve to the right of this value is 0.01. Okay, so this is kind of going back to PowerPoint. This is what we so far have summarized. The critical value is 6.63. Let's keep going. Now, if you are using a PC, you might have noticed that I have a Mac, so some of the menus are a little different, but if you are using a PC, you would go to the statistics menu, and you would use CrossTabulation and the chi-squared to run this test, which is what we're going to do next. So to do this, we're going to go to tables. Mine's a little different because it's a Mac, so you have to, it's a menu within a menu, and we're going to go to CrossTabulation and chi-squared, and it's going to ask us some questions. First of all, is the raw data in categorical variables? No. Our data is summarized as a two-way table, so we're going to switch this. And our second option is summarize data in a two-way table. We got that. It's going to ask us what columns are contained in the table. That would be our C2 and C3. Our row labels is in C1, so we're going to move that here. And so here we have, what we're going to do next is now look at the display. There's a lot of things that we can choose. What we're going to do is do a chi-squared test for association. And we're also going to look at the expected cell counts, because that also will be very revealing. So we're going to run the chi-squared test. It's good to also include the expected cell counts when you do it. So here we go. Press OK. So we have run the chi-squared test. And over here it is giving us a two-way table. Not only does it produce the original data, but it also below gives, you see this 11.59 is the expected count. This 245.41 is the expected count. And similarly 62.41 and 1,321.59. Those are all our expected counts. A couple of things do jump out. You'll notice that the expected death rate when Gilbert were working was approximately 11.5. However, shifts with a death were 40. So there is something unusual appears to be happening. If you're wondering how these expected values are determined, what you do is, let's say we wanted to figure out how was the 11.59 determined. Well, the way it works, if you're trying to find the expected value of any cell, is you first take the row total, which in this case is 257, and then you multiply that by the column total that the cell is in which case this is 74. You multiply the 257 and the 74 together. Once you have the product, you divide it by the sum of all frequencies, which in this case is 1,641. And that's how you get 11.59. A similar process could be used for any of the other expected values. It's really the row total times the column total, and take that product and divide it by the total all frequencies. That's how you determine any of these expected values. Okay, let's see what else we can learn from this. We also ran the chi-squared test, and what we can see over here is that the test statistic is 86.48 with degree of freedom 1, which is what we expected, and the p-value is less than 0.0001. Very interesting. So again, if you know where this is going, we know that our capital p-value is way smaller than our significance level. So that's something to think about as we start forming our conclusion. Okay, I'll switch back to the PowerPoint and let's talk about this a little longer. So here is a summary of what we've just done. You'll notice again when you're running the cross-tabulation chi-squared, we're going to look at chi-squared test for association, and also you want to do the expected cell counts. So this just summarizes what we just did here. Now, if we were to run this through, looking at a graph, you could see that this red marker would represent where our critical value was, and over here this blue marker represents the test statistics that we just had. Again, this is a summary of that chi-square test, and what we're trying to figure out is a conclusion, what exactly happened. So, a couple things. We have, because of this p-value, we know we are going to reject the null hypothesis. So we will have sufficient evidence to warrant the rejection to claim that depths and the shifts were independent whether Gilbert was working. So if you're looking at where this red marker over here, the critical value is, remember our original distribution graph over here had the critical value of 6.63 right here. Relatively speaking, this is an extreme rejection. It's really statistically significant, definitely not independent. And so then when we're looking at this, the test statistic was 86.48, critical value was 6.63, it's very much to the right in the region of rejection, and the p-value is less than 0.0001. So we will reject the null hypothesis. There is sufficient evidence to warrant a rejection of the claim that the deaths on shifts are independent of whether Gilbert was working. So a couple things from this. What we have just determined is that Gilbert working or not working and dying or not dying are not independent. There is a relationship between when she's on the shift and the number of people who die during that time. So, do the results favor Gilbert's innocence or guilt? Based on this, the results favor the guilt of Gilbert. Now, what the statistics did, however, is say there is something wrong and that it was statistically significant. So you can't convict a person on a crime based on a table like this, but you can definitely, it definitely raises red flags that something is amiss. And then further digging and evidence was actually used to determine her true guilt. She is currently serving life without parole. We're going to now move on to a different example which also uses the idea of hypothesis testing for independence. Okay, let's talk about the sinking of the Titanic, which was a huge disaster and is still to this day. A couple of sources where I got the data are listed here, including some background information on the Titanic. Okay, the sinking of the RMS Titanic represents one of the largest maritime disasters in modern history. It was a British passenger liner that sank in the North Atlantic Ocean in 1912 after striking an iceberg on its first voyage from Southampton to New York City. Over here you see a picture of what the Titanic looked like. Now, the number of lifeboats on the Titanic could accommodate 1,178 people, which was well below the number of actual passengers on the Titanic, which was approximately 2,200 men, women, and children. Several documentaries, websites, and movies have been made of this tragic event. I would say the one that's most famous of recent times was the Titanic movie. It was, I think, in 1997. We're going to refer to the RMS Titanic data imported from this website that Kim has mentioned above, and it was uploaded into Minitab Express. So what I mean by that is actually they do have data that was downloaded, and we can actually look, and it shows the class that the passenger was in, their age, whether they're adult or a child, their gender, and whether they survived or not. What has not been included in the data is their actual names, which actually there are historical records of who survived and who died the Titanic disaster. As you can see, there's quite a lot of information. When we look at it, it's 2,201 passengers who were on the manifest. Again, some of the records say that there were probably more people than what was listed on the passenger manifest. Okay, so what we have is, this is going to be the data that we are working with. This is raw data, so our approach might be a little different than before. Okay, let's take a look. So, again, the number of lifeboats could only accommodate 1,178 people, and there were many more men, women, and children than there were space for lifeboats. What we're going to do first is create a two-way table that lists the gender, whether the person was female or male, versus survived, no or yes. A couple of questions are how many passengers, how many survived, how many died, and what percentage of the total passengers was in each group, either surviving or dying. So let's begin. To do this, we're going to do a cross-tabulation in Chi-squared again. And so what I'm going to do right now is I'm going to switch over to Minitab, and let's do it. We're going to go to Tables. And we have these different choices. So we're interested in studying gender versus the survival, so those are going to be the variables that we're going to use. For the row, I'm going to put gender. For the column, I'm going to put survived. And in this case, we do actually have the raw data as categorical variables. So we're going to leave it as it is. Now let's just run it. It's true we have options over here for chi-square test, but right now the question is not asking us for statistical significance. It's just asking us, what are the numbers? So let's do that. Okay, so we can actually answer some of the questions already, just based on the two-way table that's been constructed. So let's take a look at some of those questions. Our first question is, how many passengers were there? Well, at least for on the manifest, there were all the passengers, when we look at it, is 2,201. That would answer that question. How many survived? That's how many passengers survived. Now, not specific to gender, just how many survived. So as we're looking at this, we would be looking at this all column over here. And 711 survived. And then the other question is how many died? It's 1,490, at least of who was known. And when you look at this number, 711 survived, and you look at the number of passengers that lifeboats could accommodate, that also would indicate that either not all the lifeboats were deployed, some were lost at sea, or they were not fully filled up. So that's a double tragedy as well. The question we have is what percentage of the total passengers in each group either survived or died? What we can do is to figure that out, we could calculate the percentage base of all passengers. For example, if we took 1,490 and divided it by 2,201, we could find out, and then you get a decimal, change that to percent. That would tell you what percentage of all passengers did not survive, meaning they died. And looking at here, 711 divided by 2,201 would tell us, and changing that to a percentage would tell us the percent of people who survived, which is, it looks like it's in the low 30s%, but we can actually do this more accurate than guesstimating. So we're actually going to proceed and do that. So just a couple things that we do know right now. A summary of what we've done so far is we chose the CrossTabulation Chisquared, and we looked at the rows and columns. And so far, this is what we have as a two-way table. So that's just summarizing currently what we've had. Now, if we want to do this a second way, what we can do is do the same thing, but this time what we're going to do is take a percent of the row, percent that's displayed in cell. Because, let's go back to our menu tab and explain why that's the case. So when we look at this, we really want to do a summarization of this row, because this is what we were using. And what we can do is find the percentages of each row. So what we're going to do is run the two-way table again, CrossTabulation Chi-squared. It's going to ask us the same questions again. So we have gender and survival, and raw data, correct. Okay, switch to display. And what we're interested in is the percent of the row total this time around. And let's see what happens. So right now we're not running any chi-square test for association because the question has not been asked whether gender and survival are independent or dependent. It will be a later question, so we will actually answer that question as well. So let's take a look at the percent of row total. So when you look at this, a couple things that pop out is when we're looking at the columns of survived and gender. So we could get the percentage of all female passengers who survived and died. We can also get the percentage of all male passengers that survived and died. And then we got the percentage of all passengers that survived and died. A couple of things that you might find interesting. To answer the question, 67.7% did not survive the trip, and 32.3% of passengers did survive. Going back to what percentage of total passengers was each group survived and died. So that's what a summary of that will take. Okay, let's go onward now. A different question is how many people were female and how many people were male, and what the percentage of total passengers was each group, female and male. So to do this, we can run this two-way table again, and this time what we're going to do is do a column total to get those totals. Because right now we've been doing totals across rows, and let's now do totals across columns to answer that question as well. So we go to tables, CrossTabulation and Chi-squared, and we're going to do gender, we're going to do survived, we're going to use the raw data, switch to display. This time we'll do percent of column total instead. So as we do this, we can then answer those questions of what percentage of all passengers were female and what percentage of all passengers were male. And then, of course, all passengers would be your 100%. So when you look at it, about 21% or 21.35% are female, and about 78.65% were male. So there were many more male passengers than there were female passengers on the Titanic. So that answers that question. Also, how many people were female? There were 470 female passengers. There were 1,731 male passengers. And again, the percentages are in the table below. Okay, so that answers the question that was at hand. And then if we're looking at what percent of males survived and what percent of females survived, again, looking back at one of our old tables that we just recently created, this would go back to gender and versus survival. And what percent of males survived? Well, looking at this, about 21.2% survived. Of the females, 73.19% of females survived. So that does tell an interesting story. And so we will also investigate this a little deeper. So we're going to now look at the test of independence, and we're going to test a claim that the gender of the person had no effect on the survival rate of the Titanic at a 0.05 significance level. As part of your analysis, include the expected frequencies for gender and survival. So let's go through this. What we're going to do now is actually run the Chisquared test. We're now going to run the statistical test. A couple of things to note. It is a two-way table, and when we go back to that two-way table, coming back to here, there row of female, row of male, not surviving and surviving. So when we're going to be looking at this, a couple of things we'll be running is the Chisquared test, CrossTabulation and Chisquared, again, gender and survival, and we're going to display. Now in this case, what we want to do is the Chisquared test for association, and we're going to do expected cell counts. And we're going to then click OK. Now, when you're doing it, you may notice that the degree of freedom is 1, and you might be wondering, well, why is that the case? Again, 2 rows, 2 columns. When you find degrees of freedom, it's always 1 less than the row times 1 less than the column. So in that case, that would mean 1 times 1, which is 1. That's why we get degrees of freedom, which is 1. Our chi-squared value, or our test statistic, is 456.87, and our p-value is less than 0.001. If we're wondering about the actual distribution, because that is part of the question, what was the critical value that we were comparing it against, what you can do is go to the distribution plot, display the probability. We do know we want to find out what the chi-square distribution for this particular situation is. We know it was 1 degree of freedom. And then our probability, our significance level was 0.05, and it is a right-tail distribution. So we could also look and see that in this particular situation, our test statistic was 3.84146 for this particular one. We also know that when we ran the test, that the test statistic was much, much higher. Chi-squared in this case was 456.87. So again, if we're thinking about what this means, the null hypothesis is that the gender and survival rate are independent of each other. The alternate hypothesis is that there is a relationship between gender and survival. So based on this, what we're looking at is we actually are going to reject the null hypothesis of independence. So let's take a look further about what this means as we work through this. So again, we're looking at the different expected counts. We'll also notice that the expected value of female surviving would have been 151.83, and the actual number of females who survived were 344. If we're looking at survival, the expected frequency of male surviving was 559.17. The actual males who survived the Titanic disaster were 367. So as we're looking at this chi-square test, we reject the null hypothesis of independence. There is something that's going on. There is a relationship. So if you're trying to just visualize where this was, that originally our test statistic was 456.87, and you'll notice that that's way out there if we were to try to put it on the particular graph. Our critical value over here was 3.84. Our test statistic is way off the chart. P-value is less than 0.001, and therefore we reject the null hypothesis. There is sufficient evidence to warrant the rejection of the claim that gender and survival are independent. There appeared to be a relationship between gender and survival on the Titanic. Okay, so the conclusion is there's sufficient evidence to warrant a rejection of the claim that gender and survival are independent. There was some relationship between gender and surviving the Titanic's disaster. And the question is, based on your findings, was the policy of women and children first when loading lifeboats seemed to be followed during this maritime disaster in 1912 for the portion of this policy referring to gender? Why or why not? Well, we have actually looked at this a couple of ways, and then finally we did do a statistical test to determine whether gender and survival were independent. And we found out we rejected that null hypothesis. When we first looked at this, and we look at the expected values of survival rate versus gender, we'll notice that when we look at it from a percentage perspective, a very high percentage of females survived and a very low percentage of males survived in comparison to the actual percentage of surviving and dying of both genders. When we look at the statistics for gender and survival, when we do the expected frequencies, you'll notice that the expected number of females who survived was much lower than who actually did survive, and the expected frequency of males surviving the trip was higher than those who survived. So again, when you look at the percentages and when you look at the frequencies, it does suggest that it does not follow the same. It does not conform to what the expected frequencies were. Lastly, when we did the chi-square test, it is statistically significant that the relationship between gender and survival are dependent. There is a relationship between gender and surviving the Titanic disaster. Furthermore, when we look at the percentages or we look at the frequencies, it would appear that females survived at a much higher rate with regard to expected frequencies than males who survived at a lower rate. So based on this, yes, it did appear that the women and children first, at least for the women part, was being followed. Now, we can run more tests, and I encourage you to run those tests if you want to find out regarding this disaster about adults and children, and also what class the person was in, whether they were in first class, second class, third class, or were they crew members. It turns out that there are also some statistically significant discoveries to be found there as well. Now, talking about the Titanic, actually in Maricopa County, there currently is an artifact exposition from now into spring 2020 on the Titanic. So if you're interested, you can see this website over here is TitanicArizona.com. Actually, there is many of the objects that were recovered from the disaster and some actual stories about the passengers and the crew members who were on the Titanic are on display at the Odyssey in the desert. I hope you found this helpful.